Hello students, welcome to the first lesson of the third quarter, which is the parallelogram and its properties. In this video lesson, our goal is to determine the conditions that make a quadrilateral a parallelogram. To start with, do you still remember the name common to these figures? Yes, they are quadrilaterals. Do you know what is a quadrilateral? A quadrilateral is a polygon with 4 sides. Now, let us organize the quadrilaterals according to its definition. Basically, quadrilaterals are categorized according to the number of parallel sides. If the quadrilateral has one pair of parallel sides, it is named as the trapezoid. If the quadrilateral has two pairs of parallel sides, it is named as the parallelogram. Under parallelogram, we have a rectangle. It is a parallelogram with all angles that are congruent. Then we have also the rhombus. It is a parallelogram with all sides that are congruent. When we combine the properties of a rectangle and a rhombus, we will produce a square, because a square is both equiangular and equilateral. If the quadrilateral doesn't have the pair of parallel sides, it is named as the trapezium. Under trapezium, we have also the kite. It is also considered as quadrilateral without a pair of parallel sides. Sometimes there are similarities between a rhombus and a kite. Therefore, sometimes kite is a rhombus. Moving on, let us review the basic parts of a quadrilateral. Let us use quadrilateral A, B, C, and D. The basic parts includes the sides. The sides are AB, BC, CD, and AD. Let us categorize them as opposite sides and consecutive sides. The opposite sides are AB and CD, BC and AD. Next, the consecutive sides, we have AB and BC, BC and CD, CD and AD, and last AD and AB. Next part is the vertices. The vertices are A, B, C, and D. The opposite vertices are A and C, then B and D. The consecutive vertices are A and B, B and C, C and D, and D and A. Last basic parts is the angles. Angle A, angle B, angle C, and angle D. The opposite angles are angle A and angle C, angle B and angle D. The consecutive angles are angle A and angle B, angle B and angle C, angle C and angle D, angle D and angle A, or angle A and angle D. When we connect the vertices A and C, then B and D, we produce the diagonals. The diagonals are AC and BD. We name this quadrilateral as quad ABCD. Quad is the abbreviation of quadrilateral. Now, let's proceed to our main lesson, which is the parallelogram and its properties. Basically, parallelogram is defined as a quadrilateral with two pairs of opposite sides parallel. Okay, let us illustrate the parallelogram. We have the parallelogram MATH. The arrow in both directions represents the pair of parallel sides, that is MA and TH. And then the other pair is MH or HM is parallel to AT. To write it, we have the pair of parallel sides MA parallel to TH, and the other pair MH is parallel to AT. Now, let us discuss the properties of a parallelogram. First, A quadrilateral is a parallelogram if its opposite sides are congruent. Okay, let us illustrate using this quadrilateral MATH. If MA is congruent or equal to TH and MH is congruent to AT, then this quadrilateral MATH is a parallelogram. Let us have an example. MATH is a parallelogram if MA is equal to 10 centimeter and AT is equal to 6 centimeter. What do you think is the measure of TH and MH? It is given that MATH is a parallelogram, so we need to apply the properties. We have TH is equal to 10 centimeter. It's because MA is equal or congruent to TH. And then the other one, MH, since MH is congruent to AT, therefore MH is also equal to 6 centimeter. Next property, we have a quadrilateral is a parallelogram if its opposite angles are congruent. Let us use the same figure, a quadrilateral MATH. We all know that angle M and angle T as well as angle H and angle A are opposite angles. If angle A is congruent to angle H and as well as angle M is congruent to angle T, then MATH is a parallelogram. Let us have an example. MATH is a parallelogram if angle A is equal to 78 degree. Then what is the measurement of the other three angles? Following the property, our answer is, since angle A is equal to 78 degree and it is also equal to angle H, therefore angle H is equal to 78 degree. Then to answer the other two angles, we will going to use the concept of the sum of the four angles of a parallelogram, which is 360. So since angle A plus angle H plus angle M plus angle T is equal to 360 degree, and angle A plus angle H is equal to 156 degree because 78 plus 78 is 156 degree. And angle M is equal to angle T. Therefore, angle M and angle T is equal to 102 degree. It's because when we subtract 156 from 360 degree, the answer is 204 degree. And we divide it to these two angles, so they are both each 102 degree. Third property, a quadrilateral is a parallelogram if its consecutive angles are supplementary. What do you mean by supplementary? Supplementary means the sum of the two angles is 180 degree. Using the same quadrilateral MATH, we all know that the consecutive angles are angle M and angle A and angle T and angle H and angle M. So, if angle M plus angle A is equal to 180 degree, angle A plus angle T is equal to 180 degree, angle T plus angle H is equal to 180 degree, angle H plus angle M is equal to 180 degree, then MATH is a parallelogram. Let us have an example. MATH is a parallelogram if angle A is equal to 75 degree. Then what is the measurement of the other three angles? Applying this property, the answer is, since angle A plus angle M is equal to 180 degree and angle A is 75 degree, therefore angle M is equal to 105 degree. Then next, to get the other two angles, since angle H plus angle M is equal to 180 degree and angle M is equal to 105 degree, therefore angle H is equal to 75 degree. Then the last angle, since angle T plus angle H is equal to 180 degree and angle H is equal to 75 degree. Therefore, angle T is equal to 105 degree. Fourth property, a quadrilateral is a parallelogram if its diagonals bisect each other. Let us use the same figure, quadrilateral MATH. To produce the diagonals of this figure or this quadrilateral, we need to connect the opposite vertices, T and M, and then the other pair is H and A. Then they are intersected at point O. If the measurement of MO and the measurement of OT is congruent to each other, as well as the measurement of HO is congruent to OA, then MATH is a parallelogram. Let us have an example. MATH is a parallelogram if MT is equal to 12 cm and HA is equal to 16 cm. Then what is the measure of MO, OT, HO, and OA? To answer this and following the property, our answer is, since O bisects MT, which is equal to 12 cm, therefore, MO and OT is equal to 6 cm. Then the last one, since O bisects HA, which is equal to 16 cm, therefore, the measurement of HO is equal to OA, and which is equal to 8 cm. Last property, each diagonal of a parallelogram divides the parallelogram into two congruent triangles. Using the same quadrilateral MATH, in the property we're referring to only one diagonal, so let us use one diagonal. Let us connect M and T, so that it will be the diagonal to be used. If a diagonal MT separates MATH into two congruent triangles, triangle MAT and triangle MHT, then MATH is a parallelogram. Let us have an example. In the parallelogram MATH, if we draw a line joining the opposite vertices A and H, what are the two congruent triangles? To answer this, let us connect the other diagonal, which is HA. So our answer is, since the quadrilateral is a parallelogram and AH is a diagonal, therefore, the two triangles that are congruent are the triangle MAH is congruent to triangle THA.